application. Okay, fine. No, that's fine. So we're going to talk. Paul's going to talk about how to package that up and how we've actually been able to deploy that out, and then Alex is going to finish up with some. How do you get involved? How can we take this forward, and then some Q&As at the end.
So, is this a good place to stand, Alex?
Yeah, you're in shot. You're all good.
Okay. Good. Right. Well, welcome in-person people and hello people watching at home around the world. Okay, so when we're talking about training AI models, the most important thing is the sheer scale of data involved. Any given teaching hospital or a hospital that's engaged in research will have teams in place that are really good at delivering clinical trials, but typically the number of patients involved in clinical trials, it might be dozens for a drug intervention trial or maybe several hundreds for an observational study. But to train AI models, you need tens of thousands or even up to 1 million data points in your data set in order to get a robust model trained. And the systems in place at hospitals just really aren't set up to deal with this, or if they are, it's on a one-off case-by-case basis where only the bigger, well-funded studies have the support to get that off the ground. So this is something that we're struggling to deal with. A big part of it is data privacy. So if you're collecting data together from throughout the country and you need to move it to where your GPUs are based so that you can physically do the training, you have to put in very good protections to make sure that patients' privacy is preserved. Often a traditional clinical trial will get individual written consent from each patient to be part of the study. But if you're looking at archival data, you can't go back and do that retrospectively. So it's the requirements to be allowed to do that are a lot higher administratively. Another difficulty that we face is getting a good demographic range within your model. So if you have a very good setup in one part of the country where you've got access to a great data set, you have some really powerful compute facilities, but all of the patients are coming from that local area, the model that you train will be demographically biased, and it will perform better on new data that looks more like the data that it's trained on. So a strong AI model will have to have a wide range of different demographics in the training data set in order to perform well on patients from different demographics when it comes to being deployed. And for that, we need to scale up. We need data sets from throughout the country at multiple different sites, from multiple different demographic groups and probably different clinical pathways too, depending on what type of model you're training. And this has been done, but typically you need a really high prestige grant and a really high prestige professor heading it up to convince different sites to buy in and simply to get the scale of funding that you need, because they'll be setting up entire infrastructures and systems to be able to gather together all of these data from multiple sites in order to make it work. So it's inaccessible to a smaller project. And as we were hearing yesterday, for AI, you need a model trained for each application. There's not one big model for all. So we need diversity in there, not just a few big projects. The final issue that we come across a lot is that clinical data is messy. Mark and I are really interested in imaging data, and in particular brain images, but the NHS has a wealth of all manner of imaging data available. But every different hospital will have different scanners. If you're looking at historical data, the equipment may be upgraded over time. Different clinical departments within the hospital will have different protocols for which scans they take. They will have different naming systems. all manner of things. And when data gets transferred between hospitals, it might lose some of its metadata, it might get names changed. In short, you've got your work cut out for you if you are manually collecting data together from multiple sites and trying to basically think of an AI model like a baby. It needs pre-chewed food. You can't just give it a steak and some carrots. And you have to do that with the data. You have to get it all in a homogenized form, all in a harmonized form, in order for the model to be able to ingest it and to be able to train on it. And that's another problem that we really face, especially when we're combining data from multiple sources. So, who shall save us? Oh, right, I forgot about this slide. This is our boss, George Cardo. He was in the Times last month or so, and I really like this one quote from the article. His point here is the technology is already here. Just in the last 2 or 3 years, what AI can do has become unrecognizable. But the challenge is administrative. It's a matter of getting buy-in, getting people at NHS trusts to trust, no pun intended, to trust you as a provider of a system or as a trainer of an AI model, that you are going to be good with their data, that the system you're installing is going to work well alongside their trust systems, and that who's benefiting from this, that the system is set up to benefit the NHS and it's not just designed to sort of extract profits from the whole situation. And so this whole issue of administrative buy-in, of generating trust is really important. And that's kind of built into the very reason for the London AI Centre for Value-Based Healthcare's existence, is enabling these collaborations between academia, commerce and healthcare, and build that sense of trust and buy-in. So yeah, there's a link to there once you get the slides. It's well worth a read. So I'll pass on to.
Yeah, so we've obviously Paul's very eloquently gone through the issues that you know traditionally they've faced. So the AI Centre came to us, yeah, like I said, probably 2.5, 3 years ago now, with an idea of Flip, and since, you want me to move there?
Yeah.
Yeah, cool. Since then, we've obviously developed it. It's deployed out into trusts, and Mark's going to talk about how people are using it. But obviously, we talked about Flip. What actually is it? So it's built on, I guess, three main components. One is the secure enclave. This is the dedicated data store within the trust. The reason we sort of do this is we can take the models to the data rather than the data leaving the trust bounds and going to the model. So we tick a box with IG and data privacy. We've got then interoperability and data harmonization. So Alex is actually going to talk about a little bit more in detail around how we standardize the data across these trusts. So like Paul mentioned about, you know, baby food, it's all got to be the same type. So we're trying to standardize out, and you know, people have been trying to standardize healthcare data for years and years. So we've taken a subset that we need for training models, and we're standardizing it using an OMOP standard, which I'll also go into. And the final bit is the federated learning. So like I said, the models go out to the actual trusts, and then they come back into the cloud environment that we've got, and they federate and aggregate and go through this loop many times. The reason we do this, obviously, is to hopefully create a generalized, robust model, like Paul said, can take in any type of images from different locations and give you a real sure sort of result out the back of it.
All right, so a little bit about efficiency. So one of the key requirements for the Flip platform when we produced it was to tackle this notion of efficiency in data in model training in the NHS. So at the moment, there's a huge issue with getting access to data, full stop. So data being housed in different NHS trusts through the country. We have developed a system where once we've hooked into a trust, it's possible to, through mapping to the existing trust processes that all trust admins would be familiar with, we can make the same requests for access, but the physically getting hold of the data and maybe moving it to where the model training can actually occur is taken away. With Flip, we have access to vast computational power through the deployment of Nvidia hardware. So we use DGXs on trusts, which contain 8 very high power GPUs, which give more than enough computational power to train models. So there's no longer a need to take data out of trust onto local workstations. So you've got data privacy issues we're touching on there, but it's much more efficient. Due to the nature of federated learning, because we're able to submit the same training requests of multiple trusts simultaneously, it is inherently more efficient as federated learning, rather than individual pots of learning and training that's occurred within each trust data set. It is, in essence, parallel. You can submit the same training requests to of your model to multiple trusts at the same time. So this is an example of how simple it is to set up a project. Project's a top-level sort of object within Flip. You set up a training project, you get your approvals, and you can iterate on multiple times on the models contained within the project. And it's super simple to set up, as you can see.
Okay, so we're going to talk about data privacy. Obviously, we've touched on that. The biggest thing is the secure enclave, so that, data not leaving the trust bounds. But it goes further than that. Alex talks about creating a project there, but the next step is actually identifying your cohort. So how do I know that I've got actual sample data at these trusts? So you're able to query this OMOP database, but we don't bring back obviously PII information. We bring back high-level demographics. So from Paul and Mark's point of view, they'll know their age ranges, their gender ranges, they'll know, sort of where people are from, and they're able then to sort of pick and choose and create a really good sort of training cohort from that. Like I say, the models actually go to the site as well, so they're using the on-premise GPUs, and then the aggregation stats go back and the loss functions and things like that. And again, nothing PII is contained with this. So the trusts are really happy, IG signed off on it. On the flip side of that as well, we've also got, patient privacy. So we also check the National Data Opt-out database to make sure that, patients that have been identified in the cohort have actually signed off for their data being used for research purposes as well. If it's not, we take them out of that pool. This is just a very simple query. It's going off to 2 trusts, so KCH and UCLH. And you can see here, unfortunately, I don't know why someone's put accession ID in there, but year of birth is quite good as well. And you see sort of you spread across your cohort that's come back, so you can see who's coming back, and you can get things like gender and other high-level demographic information back from all the trusts that are taking part in the project.
Okay, so how do we tackle that issue that Paul mentioned about demographic data gaps? One of the issues with model training that's prevalent with a lot of sort of new startups who might have a sort of fledgling model is access to data, and where the data comes from can greatly affect how your model performs against if it were to be deployed in an NHS trust in this country. So if it were to be made use of, say, for instance, freely available data that may come from a completely different demographic, then it may not be as efficient a model as if it were deployed or trained against data housed within the NHS, where it would subsequently be run and inference ran against that application. So with Flip, we've obviously deployed into multiple NHS institutions across England, and we've got a really heavy focus on buy-in in the NHS. And due to the nature of how Flip is designed, with the cohort analysis, we're able to narrow down to specific demographics that you want to train your data against, identifying whether or not that demographic exists within the data sets housed in each of the corresponding trusts, so that you know that you've got a good representation of the type of data that you're wanting to train your model against. There is a training enrichment phase that Mark will get into in a bit, where we have an opportunity to collaborate with NHS clinicians to label data housed within their corresponding trusts, to make sure the model has even more data points to train against as well.
Okay, so the I guess second to last, isn't it? Is scalability. So how can you now scale this out across the NHS? There's a couple of ways in which Flip helps. So locally, we're asking the trust to load their data in once, which immediately, makes it available to all research projects. We're not, putting in requests for, can we have this data? Can we have that data? Can we, this project needs this. We're asking for it all, load it in once, and that should be it. We also, like Alex mentioned, around the dedicated GPUs. So the problem around, actually having this computational power is taken away from Flip. We have, dedicated hardware within it. And actually scaling it out. So I think we're at a few trusts at the moment. We've got plans to onboard more within the consortium, but actually we've got a cookie cutter sort of approach to deployment now. Answer ourselves. We've deployed out to trusts. We've integrated with different PAT systems. We sort of know what we're doing to sort of sum it up, and we're able to roll out across the NHS really quickly and onboard these trusts. So hopefully, in the future we'll be seeing more of these DGXs, more of these secure enclaves popping up around the country, which will hopefully allow us to create better models in the future.
Final point to cover, I guess, is interoperability. So one of the issues that Paul mentioned was this issue of how data is stored throughout different trusts. Different systems have different ways of labeling up data, different storage structures in which the data is actually housed. Flip utilizes a interoperability data standard referred to as OMOP, which we've already given a little clue towards. OMOP is a standard data structure in which we map all data that we pull out of trusts. If you have a single data structure to train your models against, regardless of which trust it's housed within, it is a lot easier to train your models because you only have standard data sets to work against. You don't have to tweak your model every time you want to train it against however it happens to be stored in a corresponding trust. So Flip contains within it a data mapper. So as part of the importing data process, it sanitizes each of the data values that we're getting out of the trusts, out of their corresponding data stores, transforms that, and taking fields, for instance, date of birth can be stored in 10 different ways in different structures, pulls all of that out and spits it into the standard OMOP structure, so that when that model comes along and says, I want a females aged between 30 and 50 who present with breast cancer or something to that effect, it's able to easily identify those individuals within the corresponding data stores within each trust, because it's got a standard data set to identify them by. Right. So we're going to move on to a real life scenario.
Yeah, so I'm going to talk to you about what it might look like to actually train a model using Flip. And in this case, the model I've trained is a model to segment hemorrhages. And what that means is taking a 3D CT of a head on the left here, which may or may not contain a hemorrhage, which is that kind of bright white area, which corresponds to a bleed. And your model will take that as input and produce as output that blue mask there, kind of this dense mask, which says that each voxel or pixel whether or not there's hemorrhage there. And so the first step for training this on Flip is, well, let's imagine we've done our cohort queries. So we've said we want all adults with suspected strokes who have also had CT data acquired, and we pulled that in, so at each site we've got that data available. Then the first step will be to enrich that data and get it ready for training your model. So in this case, that involves some data labeling. You need these actual labels available so your model can know how to produce output labels for a certain input image. And that will involve getting someone, probably a clinician in this case, to actually produce these labels. And for segmentation, that involves actually painting on the pixels over an image to produce these masks. It's quite a time-consuming process. But for different types of model training, you might need different types of label, which can be a lot easier to acquire. So for classification problems, you might just need a clinician to say, yes, that contains stroke, or no, that doesn't contain stroke, something like that. And And at this stage, as well as getting your labels, you might also want to do other sorts of enrichment. So you might want to process your data so that all your heads are aligned in the same space and have the same field of view. You might want to do some quality control, so eliminate any scans which aren't actually of a head or of low quality, have some artifacts which make them unsuitable for training. And once you've got your data nicely sanitized and ready to go for model training, you're ready to actually produce the model training code, which you need to upload to the Flip to train your models. So a content warning here, I'm going to show you some code. So if that makes your eyes glaze over, I'm sorry, but it will be brief. And I think it illustrates an important point. So getting your model ready for training on Flip is really about populating this Flip trainer class, which just has really these two important methods which you need to look at, the init and the local train. And what I'm going to show you here is that really, if you're someone who's written a model before in PyTorch, because this code is based on PyTorch, it's really about just refactoring code you might have already written into this class to get it ready. So there's very little barrier to getting your model ready to actually train on Flip. So on the next slide, I'll just show you what the init class looks like. And it's really just all the steps you would do locally to get the model ready for training. So loading in a config file, setting up your model architecture and what that looks like, and the loss function and optimizer, any transforms you want to apply to your data. So loading in the image, and sometimes you want to augment your data to shift it around, especially during training, to kind of mock up having more examples than you actually have to make the models more robust and generalizable. So all this gets set up here. At this stage, Flip will also provide you a data frame, which kind of says where your data lives on disk, so that you can actually set up a data loader, which loads the data in during model training in an efficient manner. And then the next part is filling out the training loop. And again, if you're a model developer and you've written code in PyTorch, this will look completely standard to you. There's nothing really special here. The first line is loading a mistake dict. That's slightly different. So normally with a model, you would start with all your variables, your model, your weights, and you'd, through iterative training, improve those weights until you get to a trained model. Here you do some iterative training at each site. You train on your data at each site for a few epochs. Those training weights get sent to a central hub, aggregated somehow, like averaged, and then that aggregated model then gets sent out to all of your sites. You do some more training and you kind of iterate on that process, so your overall model kind of has information from all the sites available to it. So the first of each of these local training epochs, you kind of load in the latest and best model from your central hub. Then you just run your training on it. That's all very standard. And then the very last line is also something which is slightly different from model developer. You'll normally log your training, so your metrics, your loss functions, to see how your model is actually training. And you'll normally do that to something like TensorBoard or weights and biases. But here you just use the Flip API to send it to a central dashboard, which we'll see on the next slide. So Flip makes this dashboard available, and it shows you in the middle, you've got the kind of curves you've got, which allow you to monitor your training runs. So look at the losses and any other performance metrics, which tell you how well your model is actually doing. And here you can view all your models, kind of iterate, decide what needs to be changed, launch more runs with maybe different architectures and things like that, and kind of go through the normal data scientist workflow you need to do in order to get out a model that you're happy with and you're convinced is performant. And yeah, once you've got a trained model, you might want to deploy it. So I'll hand over to Jerry to discuss what that looks like.
Yeah, so we're going to take a little bit of time to talk about it. I think we had a talk yesterday that talked about, actually the product. So we're going to talk, about this. So we built a sister product to Flip as well, which is the AI deployment engine. And this really focuses on how can we standardize the deployment at scale within the NHS, and how can we take the work that Paul and Mark do and actually apply it to clinical settings. And that's sort of the real value of it. So it's quite different to, I guess, how a lot of trusts at the moment are, speaking to AI vendors. And even though like AI is a hot topic at the moment, actually there's very few sort of success stories around it. Trusts generally, liaise with an AI vendor. They get their hardware installed, they get point-to-point integrations, they run a clinical trial. And then unfortunately, if it doesn't quite work out, they've sort of invested quite a lot of time and effort into getting that actually into their infrastructure. It's different in a case that it's plug and play. So you get aid once, you get the platform, and then you're able to install and deploy applications. And I'll try this out, and then I'll uninstall it, and then I'll install another one, try it out, and I'll eventually find the right model for me, and I will then put it into clinical use. So we have a thing like what I've just said there around clinical trials. We have shadow mode. So the results of the AI model will just get reviewed by the clinician. Won't go back to PACS, which is their sort of imaging repository. But once we sign off, obviously clinicians don't have to interact with AID. They just send data into AID. The correct model runs, and then the data comes back out and gets attached to the actual patient's record.
Okay, so I'll talk a little bit about the fundamental sort of high-level building blocks of what constitutes AID. So we've mentioned a lot of sort of NHS buzzwords that some people might not be super familiar with, so I'll hopefully debunk some of those. PACS, for instance, is sort of like a repository of where all scan imagery data ends up within an NHS trust. So your radiologist would be logging into PACS to examine scan imagery. And also, as far as AID is concerned, that's one of the sort of key integration points for where we receive data. So a radiologist who may want to submit a scan for passing through an AI algorithm may want to log in first to PACS to do that and send it to what's called a teleradiology destination, sort of submits it to AID. Another means that we can integrate is actually directly at the scanner itself. So hooking up to your X-ray machine or your MRI scanner, that can submit, depending on the vendor, straight to AID itself. So the radiologist would also be accessing that via a workstation, which is just obviously a PC that they log into to actually access these applications. As it comes to AID, we have a key component of AID is the orchestrator. So that's Monai Deploy. We work really closely with an open source community called Monai, and we in partnership with Nvidia built the Monai Deploy components. So a PACS or scanner would submit what's called DICOM, which is just an imaging standard, and that gets sent over to AID. And that would, based on a pre-configured workflow, execute a particular AI algorithm. So if we were to receive, say, a CT scan of the head, it might trigger, as designed by the administrators within the trust, it might trigger a stroke model. If it was an X-ray, they might look for a chest nodule algorithm that might look for cancerous cells or something to that effect. As Joe already alluded to, we have this sort of notion of shadow mode or clinical review. So if the workflow was set up in a way where we didn't want necessarily to trust the AI necessarily straight away, wanted to have some clinicians to have a look over it first, that would go to what's called clinical review. So the clinician would access that and see the findings and be able to accept or reject the findings of the AI algorithm. And we collate metrics based on that, which would give the trust a chance to have an overview of how well the AI is performing against a human sort of comparison. And then, so as far as AI developers, someone who may well have interacted with flips are concerned, the requirement is really just to package up that model and the application code in a Docker image. And Paul will get into that shortly. We submit to a central app store that makes applications available for all trusts that are partnering up with the AID platform. And so an AID administrator can select an application to install, download it into their trust, and then add it within their sort of clinical pipelines, their workflows for running as and when the system receives scan data.
So what I'd like to do next is take you through a worked example of an app that we've put onto AID. Just to reiterate what Joe was saying earlier, yesterday's talk, and I've just watched a sort of overview of it, did a really good, much more in-depth discussion of why AID exists and all of the sort of system level problems that it's hoping to address. So the video is going to be available, and if you've signed up to this talk online, you should get an email through with our talk, and you can request the other talk as well. And I'd really recommend yesterday's talk as well if you weren't there. Right, so what does this look like? What I'm showing you here is an architecture diagram of the specific app that we've designed, and its central feature is that it uses Docker to encapsulate everything. That's this whale with cargo boxes on it. Yeah, animal cruelty, who knows? But the great thing about Docker is that it doesn't just encapsulate your code, but it wraps up the whole environment that your code needs to run in. So all of the dependencies and everything else will be all wrapped up in the Docker image. So no matter where it's deployed, you know that all of the dependencies that your code needs will be available to run, and you don't have to worry about any of that. It's basically a hermetically sealed box that you can run whatever you want in. So all of the red boxes in the diagram here are different Docker containers that do different steps of the app's process. The orange box that surrounds them is an Argo workflow. This is simply a definition that specifies the running order of the Docker containers and what each of the inputs and outputs are. And then around that in yellow is essentially the whole aid system that would encapsulate the secure enclave, where everything is within the trust firewall, and the inputs and outputs are where aid interacts with the hospital system. So PACS, where all of the images live, will be sending images to aid. Aid does its thing. Aid sends images back to PACS if they pass. So the hemorrhage segmenting model that Mark trained earlier on is one of the boxes in this diagram. That's the lesion detector in the middle. The bits before it just get the image ready to do inference through the model and get the lesion mask. And then the ones after it take the lesion that Mark's model has detected and describe and do some statistics about it and package it up into a nice PDF report in a format that a clinician would be used to seeing for other tests that they might be running on patients, and presents it in that familiar way. So let's have a look at the next screen. This is what you first get out when you run our pipeline. And you can see that there's the CT image there, but it's been colored in so that the lesion is orange and that the normal tissues are different shades of blue to show that it's able to identify the different normal tissues. And this is the clinical review screen that AID gives the clinician, and they can accept or reject the outputs there. And if they click accept, this is what they get. So this is the report, and it's just output in normal A4 format, and you've got the colored image that you've already seen. And then down at the bottom, you've got these more detailed tables that have a bunch of statistics about exactly how much hemorrhage there is, what brain regions have been impacted by the hemorrhage, and other statistics like the overall volume of different brain tissues. And at the moment, this is really just a minimal viable product. We wanted to reassure ourselves that we could get something to go end to end all the way through in AID. But at the moment, this isn't really something that, unless the clinician was really into sort of brain imaging research on the side, they really know what to do with. But what we're going to be adding in are predictions. So we're going to train predictive models on these various image inputs and what other information is available about the patient to predict things like estimated time to discharge, how much physiotherapy will they need as a result of the stroke, or probability of mortality, any kinds of outcomes that are of interest. We're training models at the moment to predict those, and we hope that it will be fairly straightforward to add those in, and we'll just add extra sections of the report. And the reason that we're doing this is so that the clinicians can see, okay, this algorithm is able to know what a brain is, it's able to know what a hemorrhage is, and these statistics do look reasonable. And we're not just giving them, here's the prediction. They're seeing how the sausage is made, and the prediction is based on these very detailed analyses of what's in the scan. So that's, I wanted to show a sort of real world worked example. And this is something that we've put some work into. If you have your own app that you're trying to get in, if you can package it into a Docker container or several Docker containers, you can then do what we've done, make something that will run end to end, send it to the AID guys, they will put it in the aid store, and you will get a nice aid store page for your app, and then you can talk to trusts about installing it.
And that leads very nicely onto, so how do I get involved? It really depends on your perspective, I guess. So there are 3 links on here that I think would be really helpful for anyone who's interested in this area. So if you happen to be a model developer, you may want to read up the Flip docs. That's really be a great starting point into how you get involved in potentially getting access to Flip as an application, so that you can start training a model which you may already have in the pipeline to access that NHS trust data and request for access there. If you're interested in aid and you already have an application, you're ready to run, by all means, check out both the aid or the MONI documentation that we linked to here. Hasten to add, we'll be sharing these slides, so if you're frantically getting your phone out to scan QR codes or whatever, we'll get these set out so you can access after the fact. But yeah, aid docs and MONI would be a fantastic place to access if you already have an application. And like Paul, you want to get it all Dockerized and ready for running on aid. We'd be more than willing to hear from you and help you through that process. So here's just a logo wall of people that we've been very fortunate to work with so far on this program. So Flip itself is a platform deployed at KCH, GSTT, and UCLH, and aid is also deployed at those 3, but also in addition is deployed out of Sussex, East Kent, Lewisham, and very shortly, hopefully Birmingham and Imperial, which we're really proud to be working with all those trusts. So yeah, Flip already has access to some great data sets, and we're looking forward to onboarding other trusts within the program. So here I'll flash up the Slido again. So if you've got any questions, I've got the sort of questions open on my laptop. So give you a moment to, if you've got any questions you want to tap in there.
No, that's still inside. But we take questions in the room as well.
Yeah, absolutely.
Yeah.
All right.
I was interested. Something that you mentioned was that there hadn't been a huge amount of success yet with some of the AI projects. And I was curious to know what the majority of the research is being done using that AI, and also if it covers certain areas, and what areas do you feel aren't really getting the attention they deserve by the projects that are being created? Maybe some opportunities there.
Well, there's been a big funding come out recently, so there's been 21 million funding that's come out from the NHS England. Now they've not prescribed what you should bid for or what you should do with that. However, they've sort of inclined that you should go with chest CT or breast cancer. It's sort of what they want to do immediately with that. But yeah, it's not sort of taken some trusts out of it if they want to do other things. They've probably just said you may not get the funding this time around. They really want, chest, probably chest X-ray, should I say, not chest CT. Chest X-ray is the big one that they're trying to get out, sort of for lung cancer and things like that.
We've got a hand up from Joe. Joe, do you want to unmute yourself?
Yeah, can you hear me?
Yeah.
Yeah. I'm just curious. So this is more sort of like a data science technical question. You've obviously demonstrated quite quickly, and I realized that you didn't have much time, so I apologize if this is available. But my question is basically about this idea that you've shown that you can train models directly from nothing. So I come up with an architecture, I dump in my my images, and basically update my weights and get a model spit out. I'm curious about whether there is a possibility of using sort of fine-tuning an existing network. So maybe taking sort of like a large CNN existing model that does all chest X-rays, but I want to develop one specifically for people who smoke. So I kind of like I have a smaller subset, so I can't train my model from scratch, and I kind of want to take I want to fine tune an existing network. Is that possible with the flip structure?
Yeah, I think that should be possible. I mean, you get to upload to the Flip dashboard various files, so your model training files, but you can also upload configs. And at that stage, I don't see any reason why you couldn't upload a model waste file, which is kind of your initial model, like your X-ray model that's been trained on a large data set. Get your code to load that in, and then fine tune it within Flip on a smaller data set, which is more representative of the population you want to target. So I think that would be possible. And yeah, it would be great from a data efficiency standard, because you could.
I think there's do you know about, obviously we've got that total segmentator model that's actually, and that's come from University of Basel, wasn't it? But it doesn't do prostate. So actually a couple of universities are looking at that and going, well, we wanted to do prostate, so they are looking to retrain it as well on Flip. So yeah.
And just as a last question, do you basically have access to all the PyTorch applications in Flip?
Yeah.
So as in like I could basically pull dropout or any sort of data augmentation functions that I could just pull directly from Python and use in the Flip sort of model definition function.
Yeah, and any PyTorch and also like Python packages that you want access to, I think you can just pip and install them. So like the model I showed you was trained on Monai, which is a kind of health-focused ecosystem which is built on top of PyTorch. So that's available. We can train on that. So we might need to make a request. Is that?
Yeah, well, we have an agreed list of approved packages, so you can't just pip install anything because it's on Trust Hardware. But yeah, we could share that like an approved list of packages, and if you got in touch with us and went, actually this package is really useful, we'd just review it and we could add it to that list.
Okay. Final question. Do you support, is it only PyTorch that's supported, or do you support Keras as well?
It's just PyTorch at the moment. Supporting Keras. No, because the back end is like NV Flare with this Nvidia Federated learning platform, which is built on PyTorch. So yeah, it's at the moment it's PyTorch only. I don't know if there's any scope for supporting other things in the future, but given it's not too difficult to switch from one ecosystem to another, I think probably.
Yeah, I thought that would be the case because PyTorch is a bit faster anyway. So cool. Thank you very much.
Okay, cool. We have got a question on Slido. I'll give it to you, Alex. Is it correct to say that Flip is more suitable for research purposes and model training, while AID is used for clinical applications?
Not necessarily. So I think there's definitely scope for conversations with potential commercial partners. So I think we're trying to paint this picture where Flip is training and maybe doing some research in that area, but then maybe aids for applications are already complete and trained. I think there's definitely an opportunity for commercial partners to potentially reach out to maybe further hone their applications. So it wouldn't necessarily be purely research. I think at the moment we're research around stuff.
It's the same for aid as well. We talk about aids there for commercial use, but actually, for clinical use. But Paul and Mark's model isn't used clinically. It's still part of research. We've got other research projects on there as well. And that's really the value of AID, is running these research trials with clinicians involved as well, so they can buy into it as well. So you get a mixture of both on each platform, really.
Although I think from our point of view as sort of researchers and developers, the end goal in mind, even if what you're doing is experimental, is deployment. And so all the models that we're training with a view to something that will eventually be used in the clinic. So the research that we're doing is not so much can we understand better the mechanisms of how this disease works, as it is the thing that we're training effective in predicting these outcomes that we want to predict? So it's more of a validation study, is the kind of research study that you'd be doing on Flip and Aid. Stuff that's more at the mechanistic level, at the more theoretical level, is stuff that would tend to be done on a smaller scale and in a different setting. So very much the focus is stuff that will actually be used, I would say.
Yeah, great.
Any more questions? Have we got anyone else with hands up?
Any more from the room?
No? Okay.
We were too efficient.
Yes.
How does the like approval process of getting your, say someone creates an application and they want to go through, like how, is it like, say someone does want to do it for research, is that like, does someone have to make that decision like when
That's
they're
a really good question, because well, Joe could probably give more details, but from my perspective, I've worked on a clinical trial, recruiting patients one-on-one and scanning them ourselves and going through the trust processes there. And the idea behind Flip is that the trust can use whatever processes they have in place, and Flip is a way of implementing. So the approval that each trust will really, if it's involved in research, have an R&D office that is very well versed in governance processes, in approvals processes, and so on. What they probably don't have is a mechanism for actually delivering data through that process. So Flip isn't reinventing anything to do with governance or approvals processes. It's providing a mechanism to implement existing processes that a trust might have.
I think that's it. You know, let's say I create a project and it goes out to all the trusts. Now the trust can choose whether they take part in that or not, and they can have. You know, we're not opening up all trust data. The trusts have to approve and go, yes, actually, I do want to take part in this. You know, there may be a number of reasons why they don't want to take part in it. You know, like Alex said, you might be a commercial entity and may go, actually, we just don't want to work with them. Or they may say, actually, our in-house university are building something very, very similar as well. And there may be a little bit of crossover. So there's a number of reasons why they may say no, but hopefully they say yes to more than they say no to. And that allows us to do the federation and the generalization.
And the scale could be very, very much from project to project. So for our test run of doing the stroke model, we already knew each site what they wanted, and so it was all sort of pre-approved, and it was just a matter of emailing somebody, they click the approve button, away you go. If you've got a brand new multi-center trial and you're involved in negotiations, like if it's a conventional clinical trial, usually there'll be contracts involved that have to be negotiated. The trust will receive a certain amount of money for each patient that it can recruits for the study, and then the data will get sent up to the central organizer. You might have to go through those similar sort of levels of negotiation to get your Flip project worked, and then they do the cohort query, and then each site, assuming it's signed onto the project, will then have to approve the individual cohort query and say, yes, that's within the scope that we agreed on in our negotiation. So again, what's going on outside of Flip can vary greatly in scale, but Flip's just providing a tool to, once you've said yes, to make it actually happen quicker and not have to reinvent all of these infrastructures every time you're setting up a new multi-center trial.
I think that's the thing as well, where you talked about, you know, the cohort query. Once it's approved, it's locked down. So you can't, you know, approve a study for this particular cohort query, but actually the model developer changes it at the last minute, and all of a sudden it brings in more data or less data or different kinds of data. So yeah, we protect the trust on that side as well.
I don't believe there's any further
no,
questions on that.
Actually, it's more of a topic of discussion really than a direct question and specific, but the way that I see how the models are developing is that we need a lot of data points to feed into the AI systems in order for it to learn quickly enough in order for it to learn and then produce results. And yet, on the flip side, at the moment, we have privacy by design systems that are effectively being developed for practitioners that are working with NHS or with public health data, that are effectively trying to reduce and degrade and anonymize data at many points in the process, which seem to be, two diametrically opposed kind of forces that are the main forces that I think that we're going to find are beginning to be problems when they result in the fact that we can't get enough data to feed the processes that we want to learn, and yet the processes themselves that are being designed privacy by default.
So I think the kind of processes that you're talking about are the ones where somebody will request a certain data set and that will then be packaged up and sent to them, and then they can do what they want with it. Whereas because Flip operates by training locally, the data never leaves the trust and there's no need for pseudonymization or any of that. And what we haven't really talked about yet is that whoever's using Flip never actually has the data, they don't own it. So if NHS trusts wanted to partner with commercial entities who were then, giving a financial input, they wouldn't be selling the data. If they were using Flip, they would be selling time with the data. And so it makes the NHS more in control of their own data, whereas the model where you're anonymizing it and then sending it out, once it's out, that's it. You've maybe got a one-off payment for it, but that's it. Whereas if you're employing a model like Flip, the NHS can have ongoing arrangements where the more training time the company might need, the more financial input they get. And so from what I've gleaned from people way above my pay grade is that the hope is that this can then become a self-sustaining system, in that the money that comes in from commercial interests who are benefiting from the use of the data will be enough to maintain the systems and pay people to administer the systems and so on. So it's one of these rare opportunities where, or one of these rare situations where the NHS is holding the cards, as it were, rather than the other way around, like companies taking bits of the NHS. The NHS has something very unique in its data, and if it can keep in as much control of that as possible, then it's very good for the NHS. And so that's one of the things that I think, if it's taken up and it's used correctly, Flip provides a great opportunity for the NHS to really leverage its wealth of data.
I think we've had conversation with commercial entities who are really, really interested in Flip, really interested in building their application, retraining their application, because obviously they can go to being trained on NHS data, it should, shorten the validation period. And also trusts are really interested as well, because they can leverage their data and say, well, okay, you'll be able to train our data, but we want your application as well for free. So it gives both parties a bit of leverage around it.
Questions in the room?
Could a company from like Europe or elsewhere come in, train a model over in our hospitals, and then like use their model over in Germany and stuff like that? Is that right?
It's the plan is for Flip to be international, not just NHS. From a sort of theoretical model training point of view, it's an empirical question. You train your model on NHS data, you validate it on, say, German brain scans, and it's a question of how well the percentage accuracy scores are when you actually try it out. It might transfer, it might not. It's domain shift or It depends if there's fundamental differences between the types of brain scans you see in Germany versus the types you see in the UK. Obviously, the human brain is probably the same, broadly speaking, in both countries, but maybe there's just very different clinical pathways and they take different types of scans. So there's a subtle difference in the quality of the images or what have you. So it's an empirical question for each application.
I think there's even, like you say, worldwide, you take a chest X-ray, people who necessarily from the Far East might have different, chest X-rays to what we have. There's actually sort of nationalised differences, just because of the way people live. So not necessarily training on UK data would make it a generalised model for the world. It may not work in other countries.
I think that's all. I don't think we've got any more hands on.
Thank you.
Yes, I could say, yeah, absolutely, yeah. Thanks everybody for coming along to this talk. We'll, as I promised, we'll be sending out the slides and we'll also send out a recording of this. Piques your interest or you want to or think of a question, feel free to email us. We'll absolutely be happy to either answer your question or channel those questions to someone who can. Yeah, so thank you very much for coming along. Yeah, been a pleasure. Yeah, hopefully hear more from you. Right.